I have a question for you.
Okay.
And it sounds simple. I mean, almost deceptively simple. The kind of thing you wouldn't even think twice about.
I love those. Those are usually the ones that hide, a trap door. Let's hear it.
How hard is it to tell if a file on your computer is a text file or a binary file? Is this thing a readable document, a script, a grocery list? Or is it a compiled program, an image, or just random noise?
On the surface, it sounds like a 5-second job. You double-click it.
Right.
If it opens in a text editor and you can read, "Dear Mom, send money," it's text. If it looks like a bunch of alien hieroglyphics and makes your computer beep, it's binary.
Exactly. That's the human way. But what if you're a computer? And more specifically, what if you are a programmer trying to automate that decision?
Well, then you are stepping into a minefield. Because to a computer, everything, and I mean everything, is just a long string of ones and zeros.
Yeah.
Doesn't know what a letter is, doesn't know what a picture is. You have to teach it.
And that is exactly where we are going today. We are looking at a deep dive into a post from qianmeng.org. The author is a developer named Ang, who describes himself, and I really connect with this, as an old software plumber.
That is such a fantastic descriptor. It implies he's not just typing into a void. He's fitting pipes together, managing pressure, making sure the data flows without leaking.
Yeah.
It's a very practical, hands-on way to view coding.
And Ang has been at this plumbing gig for a long, long time. His archives go back to 2011. He writes about fish keeping, gardening, photography.
Wow.
But lately, he has been on a massive, punishing journey with the programming language Haskell. We are looking specifically at Part 59, validating input text file.
Part 59, just let that sink in for a second.
Oh, no.
59 entries just documenting the learning process. That tells you everything you need to know about the depth and the sheer vertical difficulty of Haskell.
It really does. So our mission today is to look over Eng's shoulder as he builds a specific tool. We're going to dissect the problem he's solving, but I really want to focus on the struggle.
Because he admits, quite openly, that this stuff is hard. It's not one of those, learn to code in 24 hours vibes.
And that's what makes this source so valuable. Usually tech tutorials are like, here's the perfect code. I wrote it in 10 seconds. Look how smart I am.
Right.
Ang shows us the confusion, the wrong turns, and the eventual aha moment.
So let's set the stage. Ang is building a console application called XS2 ebook.
Nice name. Text to ebook.
Exactly. The goal is to take text files and convert them into ebook formats. Sounds great, sounds useful, but there is a catch.
There's always a catch.
Users are chaotic. They might try to feed the program a JPEG or an EXE file or a PDF.
And if you try to process a JPEG image as if it were a novel, your program is going to crash. Or worse, it's going to output a book filled with garbage that crashes the reader's device.
So he needs a bouncer at the door. He needs a validator. The app needs to do two things before it even starts converting. First, is this actually a text file?
Okay.
And second, does it use a supported Chinese encoding? Oh, that encoding part adds a sticky layer of complexity. He mentions UTF-8, which is standard, but also GB18030 for simplified Chinese, and Big 5 for traditional.
Exactly.
But honestly, before you even worry about that, you have to answer the primal question. Is this text?
So how does he do it? How does the software plumber check the pipe?
He uses a very classic, very reliable method called the null byte check.
Okay, let's break that down. Because when I hear null byte, I think of nothing. What exactly are we looking for?
Imagine you're scanning a book. You expect to see letters, punctuations, spaces, right? Maybe some line breaks.
Sure.
In computer terms, those are all bytes with specific numerical values. But there is one byte value, 0, that essentially never appears in valid plain text files.
It's a ghost.
It's a ghost, exactly.
Yeah.
In many programming languages, a null byte actually means stop reading, the string ends here.
Oh, okay.
So if you're writing a novel, you wouldn't put a stop reading signal in the middle of a sentence.
Okay.
But in binary files, like an image or an application, null bytes are everywhere. They're used for padding, for spacing, for memory alignment. They're as common as air.
So the logic is, scan the file. If you find a single byte with the value of 0, it's definitely not a text file.
Precisely. It's like checking a salad. If you find a metal bolt in it, you don't need to eat the whole salad to know something's wrong.
It's not just vegetables. I like that analogy.
It's a machine part.
So for efficiency, Ang decides he doesn't want to read the whole file, especially if it's huge. He just checks the first 124 bytes, the first kilobyte.
Smart. If there's no null byte in that first kilobyte, it's safe enough to assume it's text.
Okay, so in a language like Python or JavaScript, This is trivial.
Oh, yeah.
You open the file, you read a chunk, you check for 0. 3 lines of code, maybe?
Maybe 2. It's a gentle slope. You can probably guess the syntax even if you don't know the language.
But Aang is doing this in Haskell, and this is where we hit the cliff. He writes a function called isText. And immediately, we are introduced to something called data.byteString. Why not just use string?
This is the first hurdle in Haskell. In Python, a string is just .text. It handles everything. In Haskell, a string is technically a linked list of characters.
Okay.
It's actually very inefficient if you're processing a massive file. It eats memory. So Haskell forces you to be specific. Do you want human-readable characters, or do you want raw binary data?
And for this check, since we are looking for that bolt in the salad, that binary 0, we want raw data.
Right. So he imports data.bytestring. He's treating the file not as a story, but as a sequence of raw numbers.
Now, I'm looking at the function signature he wrote is text.filepath.io bool.
The dreaded I.O.
I see this IO tag everywhere in Haskell discussions. It seems to scare people. It returns an input output bool. Why can't it just return a bool? Why can't it just say true?
This is the philosophical heart of Haskell. Haskell is a pure language. It treats functions like mathematical equations.
Okay.
In math, 2 plus 2 is always 4. Doesn't matter if it's raining. It doesn't matter if you're in Tokyo or New York. 2 plus 2 is 4. But reading a file, that's not pure. The file might not exist. The hard drive might be on fire. The permissions might be wrong. The result depends on the state of the world. So Haskell wraps that result in a protective box called I.O.
A box.
Think of I.O. as a hazmat suit. The data from the real world is dirty or unpredictable. Haskell refuses to let that dirty data touch the rest of your clean, pure code.
So it says, okay, you can have your true or false, but it has to stay inside the hazmat suit.
Exactly. And here's the kicker. You cannot just unzip the suit and grab the value. You have to use special tools to manipulate it while it stays inside.
This seems like an immense amount of overhead for just checking if a file is text.
It is. It absolutely is. And Aang admits this. He says in the post, and remember this part 59, he says grasping this specific code snippet took him time.
I want to talk about that timeline he shares. It's sobering. He breaks down how long it takes to learn Haskell manually.
It's not for the faint of heart. He estimates just to understand the syntax, not to be good, just to read it without a headache, is 2 to 8 weeks.
2 months just to read the code. That's intense.
And to reach proficiency, where you can solve problems like this without looking everything up, 6 to 12 months.
He explicitly compares it to Python. He calls Python a gentle slope. Haskell is, well, it's a vertical wall.
It is, but he's climbing it. And he mentions a very modern twist in his climbing gear. He's using AI.
Yeah, I noticed that. He says he uses AI to skip the sifting through search engines phase.
Which I think is a brilliant use case for AI in learning hard topics. Haskell documentation is notoriously academic. It uses terms like monad, functor, applicative.
Right.
It reads like a PhD thesis. If you just want to know how to read a file, digging through that can be demoralizing.
So he uses the AI as a translator. Explain this error to me in English.
Right. But, and this is the key takeaway from Angsad, he emphasizes that the AI is just a tutor. It cannot do the push-ups for you. He says daily practice is the only way to reinforce the memory. If you just copy-paste the AI solution, you learn nothing.
So he's willing to suffer through that learning curve because he finds joy in the process. It's that plumber mindset again, the satisfaction of a pipe that fits perfectly.
Speaking of fitting pipes, let's look at the specific pipe that confused him. We need to do a deep dive into line 06 of his code.
Line 06. This is the monster. I'm going to read it out, and I apologize to our listeners in advance because it sounds like I'm reading a spell. It says content-bstring.take $124 bstring.read file path.
It looks like an equation from an alien civilization. You've got a left arrow, you've got a $sign inside angle brackets. It's all smashed together.
So Aang breaks this down. He says there are actually 3 ways to write this line in Haskell, and understanding the difference basically unlocks the whole language.
It really does. Let's walk through them. From the most human to the most Haskell.
Okay, method 1, the do block.
The do block is the verbose way, it looks like. Step 1, read the file. Step 2, save the result to a variable. Step 3, run a command to take the first 124 bytes of that variable. Step 4, return that chunk.
That makes sense to me. That's how I think. First do this, then do that.
It's imperative. It's sequential. But to a Haskell programmer, that's boilerplate. It's messy. You're creating temporary variables you don't need. It's not elegant.
So they try to tighten it up. Method 2, the pipeline. This uses an operator that looks like a funnel.
Bind.
They call it bind.
Yeah, this is the classic monad operator. Remember the hazmat suit, the I/O box?
Over a dirty beta box.
Yeah, right. So read file returns a string inside that box. You can't reach in. The bind operator is a special tool that takes the box, opens it up, extracts a value, and immediately shoves it into the next function.
So it removes the context, it handles the dirty work so you can just focus on the data.
Exactly. Ang compares it to mathematical composition, FGX. You are chaining functions together.
Yeah.
G happens, then F happens. The bind operator is just the glue that makes sure the data types line up.
Okay, but Ang didn't use that. He used method 3, the one-liner, the operator.
The operator, also known as fefmap. This is the cheat code.
The cheat code.
This is the mark of a pro.
How's it different from bind?
Okay, with bind, we opened the box, took the value out, and passed it on. With feminab, we don't even open the box.
Wait, how do you modify the data if you don't open the box? That sounds like magic.
You teleport the function into the box.
You teleport the function?
Think of it this way. You have a sealed room, the I/O context, with some data inside. You want to cut that data in half, take the first 1024 bytes. Instead of bringing the data out to you, you use femmap to send the cutting robot into the room.
Oh.
The robot does the work inside the room, and the result stays in the room.
That is weirdly intuitive. So content-bstring.take 241924 bstring.readFile path means read the file and then just purely map this take function over the result while it's still inside the I/O context.
You got it. It turns a multi-step process into a single, elegant definition. It flows, and that's what Ang loves about it. It's concise.
But here's my question. Is concise always better? Line 06 is elegant, sure, but it's also cryptic. If I'm a new developer joining the team, I'm going to look at $, and have no idea what's happening.
That is the eternal debate.
It feels like there's a bit of snobbery there.
There can be.
Yeah.
But Haskell prioritizes correctness and mathematical elegance over being easy for a newbie to read. The argument is, once you learn the language of the operators, once you know what $, means, it's actually easier to read.
Okay.
You see the structure of the logic immediately. You don't have to parse through 5 lines of step 1, step 2, step 3.
You see the shape of the pipe.
Exactly. And this leads to Ang's biggest realization. He says the key to mastering Haskell wasn't memorizing syntax. It was meticulously tracking the type signatures.
The inputs and the outputs.
Yes. If you know that read file produces an I/O byte string, and you know that take expects a plain byte string and produces a byte string, you can see that they don't fit together directly.
You have a box and a function that expects a naked value, so you need an adapter.
You need an adapter, and a dabble is that adapter. Ang says once you start thinking in types, thinking in shapes of data, the code almost writes itself. You stop guessing.
It's like the plumber again. If you have a 2-inch pipe and a 1-inch pipe, you don't just mash them together and hope. You look for the reducer coupling. You verify the fit before you turn on the water.
And that is why Haskell is so robust. The compiler is the strictest building inspector on Earth. It will not let you compile the code if the pipes don't fit.
Which is frustrating when you are learning. That's the pain, but it means when the program finally runs, it generally works. That's the joy.
If it compiles, it works. That is the Haskell slogan. Because you've mathematically proven that the data shapes fit together.
It's fascinating that Ang applies this plumber mentality to something so abstract. It really grounds it.
It does, and it removes the magic. It's not magic, it's just very precise engineering.
So to summarize where we've been, we started with a simple problem checking if a file is text using a null byte check. We fell down the rabbit hole of Haskell syntax, looked at the I/O monad, the bind operator, and the fafm operator.
And we learned that reading 124 bytes of a file in Haskell is a journey through category theory.
A journey that takes 6 to 12 months to get good at.
At least. And that brings us back to Ang.
I want to zoom out a bit and look at him again. Kianmeng.org. He's writing notes on Rust, notes on Go, notes on gardening, notes on fish keeping.
Wow.
He is a tinkerer in the truest sense.
He represents a kind of curiosity that I think is becoming rare. He isn't just trying to get the job done. He wants to understand the tools.
Yeah.
He's breeding fish and compiling code with the same mindset. How does this system work?
It's inspiring, but it also leads me to a bit of a provocative thought to wrap this up.
Get me.
Ang mentions using AI. We know that right now I could ask an AI model, write me a Haskell function to check for a null byte in the first 1 KB.
Yep.
And it would spit out that line 06 in about 2 seconds. It knows fafmap. It knows byte string.
It does. It has read all the documentation that Ang found so dense.
So, to you, the listener, Is there still value in spending 6 to 12 months of your life struggling up that cliff? Is the joy of Haskell, that feeling of mathematical purity, worth the pain in a world where the machine can just build the pipe for you?
That is the million-dollar question.
Yeah.
I think Ang would say yes, because if the AI builds the pipe and the pipe bursts, only the plumber who understands the pressure dynamics knows how to fix it.
The plumber knows why the leak happened, the homeowner just gets wet.
Exactly. There is a difference between having code and understanding code. And I think the struggle is where the understanding happens.
I love that. Thank you so much for guiding us through the mathematical forest today.
Always a pleasure to interpret the hieroglyphics.
And to you, listening, keep tinkering, keep fitting those pipes together. We'll see you on the next deep dive.